he talks about actually finding a model that fits a set of data. So when we were on Friday, when you were doing the first couple examples about finding linear, quadratic, exponential, tell them whether a set of data fit one of those models. Today we're going to look at, in this example, putting that together and actually finding the function that goes with it. And so it's just a matter of identifying if it's linear, identify the slope and the y-intercept. If it's quadratic, it's a little bit tougher there, but the ones we're going to look at or that you're going to encounter are basically not going to have the full y equals ax squared plus bx plus c, but probably just a value of a and maybe c there where we have a increasing it or decreasing it. And then exponential, knowing the value of a again, which is the starting point or the y-intercept, and b, that common ratio, how much is it multiplying by each time to get from one term to the next. So for linear and for exponential, those are both very similar. Okay? The b in the linear, the y-intercept is a in the exponential. And where for the linear, we have the slope, which is basically just the first difference, what's happening each time. And for exponential, it's the common ratio. So there are a lot of similarities between the two of them. So here we have a table that describes how the number of people changes. Then write a function that models the data. Use your function to predict the number of people who will receive the email after 1 week. So we've got an email forwarding system, right? So how many days have gone by, number of people have received the email. We want to find function rule for this. And then we want to figure out, all right, so how many people then receive the email after 1 week? So first of all, we're going to go through the whole process, looking at the differences and seeing if it's linear, see if it's quadratic, and if it's neither of those, if they're not the same, then we're going to look at the common ratio. This is an exponential function. So usually you can look at them and have a pretty good idea of which one it is. Like I can look at this one and see that from 8 to 56 is definitely not the same as from 56 to 392. So I know it's not linear. Right? I can see that right away. But I don't know whether that's quadratic or not. So we've got to check the first and second differences just for that reason there to make sure that it's not quadratic. Usually with such a huge increase, right, each time, it's probably going to be exponential, but we need to take a closer look at it just to make sure. So once again, our x values are all changing at the same rate, okay? All changing by ones. So we need see what's happening with the y values. In this case, the number of people who received the email. All right, so we'll check the first differences. So that means, reminder, we're going to subtract. So we can, when we're doing all of these, we should always work our way from the bottom to the top, okay? Or from the end, the last one to the first one. So 2744 minus 392, that is, oh, somebody help me out with that one. 2,352, great. All right, then 392 minus 56 is 336. All right, 56 minus 8 is 48. Okay, so we know it's not, the first differences are not the same, so we know that it's not linear. All right, so we're going to check the second differences then. All right, what's the difference between these numbers? And I can see right now that they're not the same, right? Okay, I don't need to do the calculations. That 2,352 minus 336, you know, that's 2016. And 336 minus 48 is 292. No, 288. Right. So those aren't the same. So it's not, the first differences aren't the same, so it's not linear. Second differences are not the same, so it's not quadratic. So that means we got to try the ratios, see if they're the same. So we're going to do so we want to divide them. So 2744 divided by 392. Is that the same as 392 divided by 56? And is that the same as 56 divided by 8? All right, so we have to do these. And this is going to give me the value for B. All right, so it's the common ratio. So it's R if we're talking about a geometric sequence. Okay? And it's the value of B if it's an exponential function. Well, since we know the first differences and second differences aren't the same, then they're probably going to be the same, right? Which 56 divided by 8 is 7. So this tells me, the common ratio there tells me the value of B for the exponential function. The value of A for the exponential function is when x is 0, what's the y value? So where's my starting value? What's the y-intercept? So my function here then is going to be f of x equals 8 times 7 to the power of x. Right. Starts with 8, and we're multiplying by 7 each time. Right. So if I want to find what it is after a week, that means we want to find f of 7. So we'll just put 7 in for x. And that's going to be a pretty big number. So we get 6,588,344. So after 1 week, 6,588,344 people have received the email. So we first determine, all right, is it linear? Then the first difference would be the same. If it's quadratic, the second difference is the same. If neither of them, then we try the ratio and see if they're the same. Right? And we're in this case 7. So then once we find them, then we can go ahead and find the equation from using the general forms of each of them. All right, so let's look at this, check it out then. All right, so remember, always checking first differences, see if they're the same, second differences, if they're the first or not, and then ratios. All right. Okay. Lesson 11.5 has to do with square root functions. So we'll look at solving some problems that involve square roots, and then we're going to identify domain and range of a square root function, and then we're going to do graphing some square root functions according to their transformations. So astronauts at NASA practice living in the weightlessness of space by training in a KC-135, known as the vomit comet. Who doesn't? That's like fun. This aircraft flies to a certain altitude, then free falls for a period of time, simulating zero gravity. The function y equals 8 square roots of x gives the speed in feet per second of an object in free falling after falling, or free fall after x falling x feet. This function is different from others you've seen so far. It contains a variable under the square root sign. Now, thing about the square root, right, is that you can't take the square root of a negative, we know that, all right? And whatever the sign is in front of the square root is whether it's going to be, tell you whether it's going to be positive or negative. So if there's no sign in front of it, remember it's going to be positive. Right? So a square root function is a function whose rule contains a variable under a square root sign. Here's a couple of examples of square roots. All right. So the function y equals 8 square roots of x gives the speed in feet per second of an object in free fall after falling x feet. Find the speed of an object in free fall after it has fallen 16 feet. Right. So since x represents how many feet it's fallen, then we're just going to put 16 in for x. So square root of 16 is 4, so 8 times 4 is 32 feet per second. So after falling for 16 feet, this object is now falling at a rate of 32 feet per second. So the farther it's gone down, the faster it's going. So it's picking up speed as it drops. Okay. So find the answer to B, and then once you've got that done, you need to get your Chromebook out and go into Desmos, because we're going to use Desmos then for a little bit. So find B, and then get your Chromebook out. All right, so we're going to look at some effects of changes in the square root function. So first of all, one thing to remember is we cannot take the square root of a negative number. Right? So the domain of a square root function is restricted to numbers that make the value under the radical sign greater than or equal to 0. So here's the graph of f of x equals x squared, the square root of x. This is what we call the parent function. It's the main thing, all right? It's just the square root of x. The domain is x is greater than or equal to 0, and the range is y is greater than or equal to 0. Okay? So reminder, we're talking about with domain, we're talking about the x values. So this graph starts at x equals 0 and goes to the right. Okay? It starts at y equals 0 and goes up. All right? And it continues forever to the right and continues forever going up. All right? So what we're going to do is we're going to use our use Desmos to explore what happens when we change certain things to the parent function square root of x. Right? So we are going to look at two things. All right? And now, let's just do this first. Okay? So on Desmos, all right, you're going to put y equals the square root of x in first. All right, so you have the graph of that function. And then I want you to put in the square root of x plus c. And when you do that, it's going to ask you if you want to add a slider. All right, and you're going to say yes. Right. So just start with them. Yeah, we'll go ahead and put it all in. Okay. And then you're going to put y equals square root of x minus a, and it's going to ask you if you want a slider, and you're going to say yes to that. Okay, so you should have the same 5 here as I do to start with. So here's what I want you to do is we're going to check changes in C and changes in A and tell how the domain and how the range changes when we do this. Okay, so you're actually going to make a table. Let's see, what do we want? I'm just going to put a bunch of them here. All right, we're going to pick 5 numbers, 5 positive numbers, or you're going to choose them, 5 positive numbers and 5 negative numbers. Okay. All right, so and then we're going to do this, okay? We're going to do, what is the domain for each one? What is the range for each one? And then we're going to tell what did it do to the graph, okay? So then basically so what happened to the graph? All right, so you'll pick a number, let's say it's 3, for instance, okay? And then when you put 3 in, so I have the square root of x plus 3, okay? So I can do my slider to where it goes to positive 3, okay? Then I'm going to tell, okay, what's the domain here? Is the domain, remember, we're starting with the domain as x is greater than or equal to 0, okay? Did that change or not? Okay. Then we'll look at the range. The range in the parent function is y is greater than or equal to 0. Did that change? All right, so in other words, where it started on the y-axis, does that change? All right. And then what happened to the graph? Did the graph go up? Did it go down? Did it move to the left? Did it move to the right? Okay? Now, does that make sense? All right, so you're going to pick 5 positive, 5 negative values for A and C. Okay, so you're going to do C first and then A, and then tell what happens with domain and range. So we're starting with x is greater than or equal to 0 for domain, y is greater than or equal to 0 for range, and look, see what happens. All right, so go ahead. Okay, so we're going to tell what happens with each of these then. All right, so we know that if we just look at the square root of x, here's what our graph looks like. All right, the domain is x is greater than or equal to 0. The range is y is greater than or equal to 0. All right, and so when you put plus c in here, all right, so square root of x plus c, and you could see that when c changes, the graph is either going up or down, right? What changes when the graph goes up or down? Does the domain change? No, because domain is the same. It's starting on the y-axis, and it's going to the right. Right? So the domain stays the same. Right? So domain is still x is greater than or equal to 0. Okay, but the range changes, right? Because that starting value for the y changes. How does it change? So if I so let's see where we are right now. Right now I have it at negative 4.57. Okay? So what's the range for this graph then? What's, Zoe? Okay, great. Y is greater than or equal to negative 4.57, all right? And if I move it some more, if I move it over here to, there we go, 3.5, now the range is y is greater than or equal to 3.5, right? Okay, so my range is going to be that y is greater than or equal to what? Whatever your value of c is. Y is going to be greater than or equal to c. Okay, so whatever that value is, that's my range then. So what happens to the graph? Okay, if c is greater than 0, it goes up. If c is less than 0, it goes down. Hopefully you found that out, right? Okay, if you did a nice little write-up of what happened there. Okay, so look at the other one. If we have x minus a, so in other words, it's underneath the square root sign now. All right, so this was, plus c was a vertical transformation, or vertical translation. The graph either went up if I had c was positive, went down when c is negative. All right, so let's look at what happens with x minus a then. All right, if I move it to the left, which means I've got a as negative numbers, then it's going left, right? The graph is going left when I have negative numbers. It's going to the right when I have positive numbers. So what's changing there, domain or range? Okay, the domain is changing because x is changing, all right? So when a is 5.3, the domain is going to be that x is greater than or equal to 5.3. If it's over here at negative 7, then the domain is going to be that x is greater than or equal to negative 7. All right? So the domain x, all right, x is greater than or equal to the value of a, the range, still x or y is greater than or equal to 0. Okay. And graphing it, if a is positive, it moves it to the right. And if a is negative, it moves it to the left. Now, here's the thing though, okay, that you have to think about. So let's look at an example here. When a is negative, that means it's going to be y equals the square root of x plus some number. All right, because we're doing subtracting a negative number. When a is positive, it's going to be y equals x minus the number. Okay, because in this case here, a is negative 3. In this case here, a is positive 3. Okay, so you have to determine what the value of a is. Okay, all right. So, finding the domain of each square root function. We know the domain has always got to be positive. Now, we could graph these and find them. Let's take a look at what happens if we're not going to graph them, though. All right. We know that the domain for square root of x is greater than or equal to 0. All right. We can't take the square root of a negative number. So when we're looking at domain, we have to take a look at what's under the square root, what's under the radical, and say that that's always got to be greater than or equal to, that part must always be greater than or equal to 0. All right. So in this case, this situation here, we have x minus 4. Well, the domain is going to be x is greater than or equal to 4. Which that makes sense because our value of a was 4. So the domain would be x is greater than or equal to 4. For b, the value of a is negative 3. So my domain, x is greater than or equal to negative 3. All right, so it says find the domain. So all I need to do is identify the value of a and plug it in for the domain. A equals 4. Domain x is greater than or equal to 4. A is negative 3, so the domain x is greater than or equal to negative 3. Because those are horizontal translations. So anything that's under the radical is going to change the domain, as far as if I'm adding or subtracting. All right, graphing. Oops. And you're going to be graphing, okay? And that's where pretty much why we worked on that and looked at that, all right? As far as what do I do with the graph? So we always have the graph of the square root of x. So here I'm going to graph these two functions. Square root of x minus 3 and 3 square roots of x plus 4. And I made my window here so it goes from negative 2 to 9 for at the moment. Okay. Now I use from basically 0 to 9 because I have specific points that I like. All right. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. Okay? Because I can use those points for moving my graph. So here, square root of x minus 3. Well, we looked at this. All right? We said in this case, since it's underneath the square root, the value of a is 3. That means that I'm shifting the graph 3 units to the right. Okay? So that means I will have my starting point. This point here has moved 3 units to the right, which means then that this point here is moved 3 units to the right. And this one here is moved 3 units to the right. So then I can draw my graph. Take that parent function and move it. Now this one here changes that quite a bit. It's 3 times the square root of x plus 4. Okay. So we have to take a look at it a little bit differently. Because what does this 3 in front of the radical tell us to do? What's that 3 tell us? To do what? What happens when I put a number in front of anything? What does that mean to do? Add, subtract, multiply, divide. What does it mean? Okay, it means to multiply, right? Okay. So, if I'm going to graph this then, okay, I'm going to use my favorite numbers, which are going to be 0 for x, 1 for x, 4 for x, and 9 for x. Because those are ones I have a perfect squares, all right, square root. So to start out, 3 times, so I'm going to multiply these y values by 3, and I'm going to add 4 to them. All right? So 3 times 0 is 0, plus 4 is 4. 3 times 1 is 3, plus 4 is 7. 3 times 2 is 6, plus 4 is 10. All right, so my new graph then is going to look like this. All right, so it's actually has what we call a vertical stretch to it. All right, stretched out vertically plus shifted up 4. All right, and remember on these graphs, do not put an arrow on this left end, okay, because that's where it starts. All right, it doesn't keep going there. It starts there and goes to the right. Starts and goes to the right. Okay. All right. All right, so with the radicals, the square roots, all right, looking at domain and range, Hopefully you have a good idea of them. And in graphing them, just take the parent function and graph it according to what we looked at. All right.